Linear relations. So, how can you tell that a relationship is linear? What does linear mean? Well, linear means having to do with a line. From a graph, you check, is the graph a line? From a table, you'll look at, does every pair of points have the same slope? Same slope is the key here. From an equation, are all operations addition, subtraction, and multiplication, and the variables aren't multiplied together? So this is harder to see, but there's no division, no square roots, no exponents, and we aren't going to do x, y. Is there a pattern of repeated addition or subtraction? Repeated addition or subtraction. So that should be familiar because repeated addition is multiplication. So really it's saying, will we multiply to do something? Over time, we're adding something, so that will turn into multiplication. Or as the number of sales goes up, that's not necessarily over time, but over some repeated addition, something will happen. So, this one, is this a line? Well, no. So this is nonlinear. Here, it's a little bit sloppy, but it's supposed to be a line and would be linear if that were actually straight. This is still linear. It's not going to be a function because it doesn't pass the vertical line test. There are multiple points with the same x-coordinate, but it is linear. All right, in order to tell whether this is linear, we need to find out whether the slope is the same throughout. So we're adding 1 and we're adding 3. That's fine. Let's check whether that's consistent. So we're continue to add 1 and we continue to add 3. So as long as this pattern stays consistent, we would say that is linear. As long as they're both addition or subtraction and it's the same slope, then it's linear. Here, we're adding 1. We're adding 1. Yeah, that's all good. And let's see what the slope is. So this slope is -2. This slope is -2. Okay, then yes, this is linear as well. Here, we're adding 1. That's all good. So this slope is adding 2. This slope is adding 4. This slope is adding 8. So the slope is not the same throughout. So it is nonlinear. Now some of you might look at this and say, oh, well, let me instead look at this as times 2, times 2, times 2, times 2. This is not talking about slope. This is talking about a different idea. It's not linear. The term for this is exponential, and we haven't talked about exponential functions yet. But when you're repeatedly multiplying, that's no longer a linear function. Here, there's addition, there's subtraction, there's multiplication. The variables aren't multiplied together, so this is linear. Here, there's addition, multiplication. The variables aren't multiplied together. This is linear. Here, there's addition, multiplication. Oh, there's an exponent, so that makes it nonlinear. Here, the variables are multiplied together, so that makes it nonlinear. Here, there's subtraction, multiplication, subtraction. The variables aren't multiplied together. This is linear. Here, there's square root, which makes it nonlinear. So going back to the original rules, we're looking for, is the graph a line? Does every pair of points have the same slope? Are we restricted to addition, subtraction, multiplication, and not multiplying variables together? And is there a pattern of repeated addition or subtraction? Thank you.